Hello, welcome to the video for lesson 8.3 on multiplying monomials. First of all, we're going to review what a monomial is, and I just copied this picture from the notes from lesson 8.1. Remember, a monomial can be one of three things. It can be just a plain number, it can be just a variable by itself, or it is a product of those things. It can be, a longer item. So these are just the examples that we did from lesson 8.1. We could also, go longer and add some exponents. So another example, excuse me, of a monomial could be something like 2a to the 4th, b to the 7th, c. That is a monomial as well. It just has some exponents in it. So that's just a review of what a monomial is. Now, there are more words that you need to know as we go forward with this unit. Some of these words down here at the bottom you probably have seen before, but we just want to make sure that everybody understands what they are. First, for a constant, that is just a monomial that is just a real number. A constant is just another word for a number that is like by itself. So it could be, a positive number, a negative number, a fraction, or a decimal. So some examples of constants are like the number 21. That's a constant. The number -5 is a constant. The number 3/4 is also a constant. And just to throw in a decimal, the decimal 0.13 or 1300ths, that is also a constant. So a constant is just a number. A coefficient is also a number, but it's a number that is part of a monomial because a coefficient is a number that is multiplying a variable. So up at the top in those examples, like when I have 12x, when I have 12x, the 12 is a coefficient because it is multiplying the variable x. A coefficient could also be multiplying, like a group of variables. For example, in the example that I wrote up at the top, the new one for today, the 2a to the 4th, b to the 7th, c, the number 2 is also a coefficient. It is multiplying, it looks like, it's just multiplying the variable a to the 4th. It's multiplying a to the 4th. So that is also called a coefficient. A lot of times we just say that a coefficient is the number in front of the variable. And remember, if you don't see a number in front of a variable, like if you just have a plain old x, there's an invisible 1 in front of it. So a coefficient could also be the number 1. A coefficient could also be a fraction. If I have the expression -1/2 x, -1/2 is the coefficient because it's a number that is multiplying a variable x. Okay, let's move on to the other three words. They're all very closely related. A power is really the entire expression when we have like an exponent and a base. So when you have an expression of the form x to the n, this entire expression is really what the power is. So it's that whole thing. Then when we talk about exponent, you refer to the power. So it says in the expression x to the n, which that entire thing is a power, the n is the exponent. And I think you guys know that. Maybe you've forgotten. But the exponent is the little number, the number that is, up and to the right of the bigger number, which is x. So in the expression x to the n is the exponent. And lastly, with the word base, again, you're working with a power here. So in the expression x to the n, which is a power, x is called the base. So you're going to hear me say these words, constant, coefficient, power, exponent, and base. as we work with learning how to multiply monomials. When we are multiplying monomials, there are three main rules for the different types of problems that we are going to see. So you see this table here has the names of the three rules. We're going to define the rule in the first box, and then we're going to work with examples in the second box. So the first rule is the product of powers. So the product of powers says to multiply two powers that have the same base, you add the exponents. It's really key that the powers have the same base. If they don't, then you can't do anything with them. You can't add the exponents. So if they have the same base, you can just add the exponents to simplify the expression. In symbols, this looks like kind of a formula here. A to the m times a to the n. This is a product because it's a multiplication problem. Product means multiply. It's a product of two powers. They have the same base, which in this problem is the letter A, so that means we get to add the exponents. So we would simplify this. Now, since m and n aren't numbers, to show that we're adding the exponents, we just say it's A to the m plus n. If they were actual numbers, we would be able to add them, and we'll see that in our examples. All right, so the first example here, let's just start with, well, let's see. Here, there we go. First example, we have x to the fourth times x to the 12th. This is a product, because it's a multiplication problem, of two powers, and they have the same base, which is x, so we just add the exponents. 4 plus 12 is 16. Notice that you keep the same base. The answer is going to be x to the 16th. You don't change the base, you just keep the same base and you just add the exponents. Okay, example number 2. Let's put some coefficients in here. So let's say we have 3n squared times 5n to the 7th. Okay, well, the powers have the same base because the powers are the n squared and the n to the 7th. They have the same base, which is n. This problem also has constants or coefficients, and that's the 3 and the 5. You do actually get to multiply the coefficients together. So that's the first thing to do, is to take the 3 times the 5, which is 15. And then you work with your variables since they have the same base, and this is again a multiplication problem. You are going to add these two exponents together. So that'll give us n to the 9th. So my answer there is 15n to the 9th. Let's do one more of these. Problem number 3 here. In parentheses, you have 4, maybe, there we go, a, b to the 6th, close your parentheses. Then you have another set of parentheses, and this means times. This is a product, because these parentheses are written right next to each other. Negative 7a squared b to the 3rd. Okay, so when I have a problem like this, I just start with the beginning of each monomial. Okay, remember, a monomial is a product, or can be a product, of numbers and variables. So each set of parentheses here is a monomial that we're multiplying together. So we just start with the numbers, the coefficients. 4 times -7, that's -28. Then you work with your a's. This is a, I don't see an exponent, that means it's a to the first times a squared. So I add those exponents together. That's a to the third. And then I look at the b's. This is b to the sixth times b to the third. And again, I add those exponents together, so it's b to the ninth. So that's my answer, -28, a to the third, b to the ninth. I do want to throw one other example in here, just so that you see an example of a problem like this. If I asked you to take x to the fifth times y to the second, and I asked you to simplify that, if you think the answer is xy to the seventh, you're wrong. That's not it. This problem cannot be simplified because they don't have the same base. Remember that? They have to have the same base in order for us to be able to do anything with them, like add the exponents. So for this one, you would put like already simplified for the answer. So let me just write that over here. Already simplified. Okay, you can't do anything with it because they do not have the same base. So just watch out for that. It happens every now and then where they try to trick you. Okay, in our second rule, it's called power of a power. Sometimes I actually call it power to a power. And I'm going to start with the example here. An example of this is when I have the power like a to the m. That's a power. When I take that to another power like that, that's where I use this rule. And the rule is that I get to multiply the exponents together. Oops, here we go. Multiply the exponents. And so this expression would simplify to give me a to the m times n. And again, m and n are usually going to be numbers. So, if the numbers are 3 and 4, you multiply them together to get 12. It would be a to the 12th. Which brings us to our first example. Down here in the next box below, the first example I had planned was to take y to the third, but then take it to the power of 4. So this is a power of another power, or it's a power to a power. So again, just using our rule up there, the rule tells us that we need to multiply the two exponents together, and it would give me y to the 12th. And that's it. Again, notice the y didn't change. I just keep the base, and I just multiply the exponents. So a second example of this. I like this one. Using numbers here, let's say I have 4 to the 5th, and then I'm taking it to the 7th. So this is a power of another power. I can simplify this expression by just multiplying the two exponents. So the base of 4 is going to stay the same, and then I just take 5 times 7, and 5 times 7 is 35. So to simplify the first expression, it simplifies to give us just 4 to the 35th power, which you don't have to figure out what that is at this point when you have that large of an exponent. That would take a really long time. You have to take 4 times itself 35 times. So I don't even know if your calculator will do that because there's a point where your calculator can't go any further with exponents. So it's okay to just leave it as 4 to the 35th. And a final example of this, let's say I go kind of crazy here, and we have 3 to the second. We're going to take that to the third, and then take that and square it again. So that's 3 to the second, to the third, and then to the second. Well, this is just like a power of another power. So it just kind of extends it. Instead of having 2 exponents, you have 3. The idea is still the same. You want to multiply these exponents together. The base is going to stay 3. And then you take your 2 times your 3, which is 6. And then 6 times the 2, which is 12. So this simplifies to give me 3 to the 12th. Okay? That is the power of a power rule, or as I sometimes call it, power to a power. In our last rule, it's called power of a product. And the idea is that you're going to find the power of each factor. And a factor is something that you multiply together to get a product. And so the factors are the items of the monomial. So in this example right down here, you have a product which is AB. That's a product because you're multiplying A times B. And you're taking that to a power. So it's called the power of a product AB. So the idea of this is that what you do is you just find the power of each factor. It's kind of like distributing, but instead of distributing a number in front of parentheses, you're distributing your exponent. So it's kind of like backwards. So again, to simplify this, you would just take A to the M, whatever that is, and you keep it times B to the M. So let's look at an example here down below. Example number 1 right here, we have in parentheses, you're going to have a product. And that product is 3xy. That's a monomial there. And we're taking that to a power. We're going to find the power of that product. And like I said with the distributing, you just take the exponent of 2 and you just make sure that each item that was part of that product gets squared. So that's like 3 squared, and then times x squared, and then times y squared. Now, you do want to simplify as much as you can, and the only other thing we can do here to simplify is to actually take 3 squared, and 3 squared is 9. So you would just simplify this to be the answer 9x squared y squared, and that would be it. Okay, our second example with this is we have a negative 2 x to the third y to the fifth, close the parentheses, that's your product. You're taking it to the power of, let's go to the power of 3. Now, as you distribute this, you got to be really careful when you have negatives. If you're using a calculator to do your negatives, make sure that you keep the negative number in parentheses. So again, if you're putting a calculator, or if you're using a calculator, you want to put like negative 2 in parentheses and then do your exponent of 3. And if you have a scientific calculator and you don't know how to do that, please make sure that you raise your hand and ask a teacher to help you. We are more than happy to help you learn how to use your calculator so that it benefits you throughout the rest of the year and on the ECA and next year and so on. So make sure you ask if you don't know how to use your calculator. So then as we do the variables, you actually want to remember the last rule, the second rule that we just did, the one in the middle of the table. Because this x to the third, you're taking it then to the third. That's the power, that's a power to another power. So that means we're going to be multiplying those two 3's together. So that will give me x to the 9th. And then the same thing with the y. This is y to the 5th, and then we're taking it to the power of 3. So that means that we need to multiply the 5 and the 3. So that will give me y to the 15th. And as I mentioned before, if you're using a calculator, the only thing we need to simplify here is the -2 to the 3rd. Now, if you're not using a calculator, you just want to remember that that means -2 times -2 times another -2. And just be careful with your negatives. The first two negatives will give me a +4, but then that times the other -2 will give me a -8. So the final answer here will be -8, x to the 9th, y to the 15th. Okay, those are the basic rules for multiplying monomials. We're going to do a few more examples on the back, as well as we're going to apply this to area and volume. Alright, so let's use what we learned on the front side of the paper, on the first part of the video, to do these examples. So for example number 1, we have, this is a product of two monomials. We have coefficients to multiply together. So this is going to be 6 times 5, which is 30. Then you want to look at your c's. This is c to the 1st, and then times c to the 5th. They have the same base, so you add the exponents. So that'll be c to the 6th. And then with our d's, we also are going to add the exponents. So d to the 5th times d squared will be d to the 7th. And that's our answer. Number 2, this is where we are taking a monomial, or a power here, and we're taking it, wait a second. We're taking a monomial to a power. And so this is where we want to distribute that 3 and just take everything that's in the parentheses to the 3rd power. So this is like that 3rd rule from the front side. So this is 7 to the 3rd. And we'll figure out what that is. And then with the b, you have to multiply. This is b to the 3rd. I apologize for that. Okay, so here we go with example 2 again. So 7 to the 3rd, and then the b's, you're going to multiply these two exponents together because it's a power right here, and you're taking it to another power. So that would be b to the 9th. And same thing with your c. So you're going to multiply the 6 times the 3, and that'll give you 18. So c to the 18th. The only thing to simplify is to take 7 to the 3rd, which is 7 times another 7, and that gives you 343. So your final answer is 343, b to the 9th, c to the 18th. And that's it for that one. Alright, with example number 3, we see something we haven't seen yet, which is a fraction. We're squaring this product in here, so that means you have to take the -3/4 and square it. It's -3/4, and you're going to square it. And you also have to take d and square it, which is the easy part, d squared. The fraction, you can do it on your calculator if you have a scientific one. You want to make sure that your answer stays a fraction. You don't want to write it as a decimal. And since it's negative, make sure you keep the parentheses. And again, if you need help using your calculator, please ask. If you don't have a calculator, or you just want to know how to do it without, remember that squaring means just simply taking something times itself. So off to the side here, I can write this as -3/4 times itself, -3/4. And with multiplying fractions, you just go straight across. -3 times -3 is +9. And on the bottom, you get 4 times 4, which is 16. So this will actually give you 9/16 d squared, or d to the 2nd. And that is it. That's your answer. Okay. And number 4, this one's fun. We have a few steps on this one. First of all, we have these 2 monomials, but they're both being taken to powers. The first monomial is being squared, and the second monomial is being taken to the 4th. So what you want to do first is simplify by taking these monomials to their respective powers here. So this is like distributing with each of those powers. So this will be 8 squared, 8 to the 2nd, and then this is g to the 3rd, and then it's being taken to the power of 2, which remember you want to multiply the 3 and the 2 together because it's a power to another power. That's the second rule from the front of your paper. So the 3 times the 2 is 6, so that'll be g to the 6th. And then you do the same thing with the h. That'll be h to the 8th. 4 times 2 is 8. Okay, then I'm going to put a big dot for multiplying. So then you go with your second monomial. You're going to have 2 to the 4th. Okay, and then it's like we're distributing this 4 here. G, well, let's see, this is g to the 1st. And you're then taking it to the 4th. 1 times 4 is still 4, so that'll be g to the 4th. And then same thing with the h to the 5th, and then to the 4th. So take the 5 times the 4, so that'll be h to the 20th. Big exponents. So now this problem is really, we're going to use our first rule. We're going to figure out our constants or our coefficients here. This is 64, and 2 to the 4th, you can do it on your calculator or by hand if you want. 2 times 2 times 2 times another 2. That's 16. So we have 64 g to the 6th, h to the 8th, times 16 g to the 4th, h to the 20th. We're almost done. You're going to simplify this by taking your coefficients times each other. 64 times 16 is 1024. Then, since we're multiplying, with your g's, this goes back to our first rule. They have the same base, so you're going to add your exponents. So this will be g to the 10th. And with your h's, that'll be h to the 28th. So that is our answer, 1024, g to the 10th, h to the 28th. Okay. With the problems on area, if you don't know your formulas, just look on the back of the Unit 8 checklist, and there are some formulas there that should help you out. For 5 and 6, we're working with area, and on number 5, it's a circle. So the formula for the area of a circle is A equals pi times the radius squared. So what we just have to do here is plug in the radius for r. Remember, the radius is the segment that just goes halfway across the circle like this one does. If they give you something that goes all the way across the circle, you want to take half of that. Okay, so for this problem, you just plug in, you go pi, and then plug in your radius. So in parentheses, I'm going to put 6x to the 3rd y, and then I'm going to put the squared on the outside of those parentheses. So we're using the third rule, which was the power of a product, and that's just where we basically are distributing that exponent to each item inside of those parentheses. The pi is just going to hang out in front for right now. We'll move it at the end if we need to. And then you have your 6 squared. I don't mind if you do that right away. 6 squared is 36. And then remember, with your exponents, you're multiplying them because it's a power to another power. So that's x to the 6th, because 3 times 2 is 6, and then y to the 2nd. The only other thing to do, well, two things to do, is you don't really want to start with pi. You kind of treat pi almost like a variable. You don't want to multiply and say, oh, well, pi is 3.14, so I'll just take 3.14 times 36. Don't do that unless the problem, wants you to come up with an actual, whole number answer or, decimal answer. It doesn't want us to do that here. It just says express the area of each figure as a monomial. We can't get an actual number answer because of those x's and y's. So the only thing to do is, instead of starting with the pi, we're just going to move it to go back behind the 36. So our final answer will be 36 pi x to the 6th y squared, and put a label on it. The label for area is units squared. And that's it. For number 6, that's a triangle, and if you look at your formula sheet, it'll tell you that A equals 1/2 BH. That's 1/2 times the base times the height. So here, we're going to start with that 1/2 because it's part of the formula. And then the base of this triangle is 4AB C to the 3rd. And the height of the triangle is 6 AB to the 4th. You can apply the 1/2 at any point. You could do it right now and just take half of the first monomial, and that would just turn the 4 into a 2. I am going to go ahead and do that. With the 1/2 is just treated like a coefficient, like the 4 and the 6 are. So you're just taking 1/2 times 4 times 6. Well, half of 4 is 2, and 2 times 6 is 12. So that's taken care of right there, the 1/2 is. So then the only other thing to take care of are all your variables. The a's, that's like a to the 1st and another a to the 1st. So you're adding those exponents together, and that's a squared. The b's, the first b has that invisible 1 as the exponent, so it's b to the 1st and b to the 4th, so that'll be b to the 5th. And don't forget about your c, it's just c to the 3rd, there's not another c in the other monomial. The last thing to do is just to put that unit squared on there, because that's the label for area. Units squared. So that's it. 12a squared, b to the 5th, c to the 3rd, units squared. And lastly, we're going to work with some volume formulas. Again, these are on the back of your checklist. The first one, number 7, that is a rectangular prism, otherwise known as a box. The volume formula for that is just simply to take the length times the width times the height. And technically, any of these numbers can be the length, the width, or the height. Just don't repeat them. So I'm going to say that the bottom here, that's the length. So we are simply just writing this as the problem x, y to the 4th. That's the length to me. The width to me is y, so I'm just going to put that times y. And the height is how tall the box is. So to me, that's x squared, y squared. And then to simplify this, really you're just using your first rule that we learned on the front of the paper. Put all your x's together by adding the exponents. So that's x to the 1st times x squared, so that's x to the 3rd. And put all your y's together by adding the exponents. So this is y to the 4th, y to the 1st, and y squared. 4 plus 1 is 5, plus the 2 is 7. So y to the 7th. The label for volume is units cubed, or units to the 3rd power, because there's a 3rd dimension to these figures. So the volume of this rectangular prism is x to the 3rd, y to the 7th, units cubed. That's it for that one. Lastly, we have a cylinder, and if you check out your formulas, the volume of a cylinder is pi times the radius squared times the height of the cylinder. So again, pi is just going to hang out in front for a little bit. The radius is halfway across the circular part, so the radius here is 4n, but we have to square it, so I'm putting it in parentheses. And then the height, I'll also put in parentheses, that's just the 7n to the third. That's the height. You want to square your radius first, and then multiply it times your height. So we'll keep the pi in front. The radius squared, that's 4 squared, which is 16. And then the n also gets squared, don't forget about that. And then that needs to be multiplied by the 7n to the third. So the 16 and the 7 get multiplied because they are just coefficients. 16 times 7 is 112. So we'll go pi and then times 112. And then we have n squared and n to the third. Those exponents get added. It's our first rule from the front. So that's n to the fifth. The last thing to do is to put the pi after the first coefficient, after that coefficient. So 112 pi n to the fifth units cubed is the volume of that cylinder. Alright, you are ready to move on to the practice quiz and to just do some work on your own.